going to be talking about angle relationships in triangles today. So this is section 4.2, and when we lead off section 4.2, what we're trying to remember here is when we're talking about the angle relationships in triangles, inside of a triangle, a couple of things are always true. It's going to have three sides, it's going to have three angles, but regardless of what any of those angles are, the triangle angle sum theorem tells us that the sum of the angle measures is going to be 180, okay? Regardless. So it's always going to be 180. This is our key right here. So regardless of if it's obtuse, if it's equiangular, if it's acute, isosceles, anything, the angle measures are going to add up to 180. And to do this, there's a little proof, and it's pretty slick the way this proof works. So I want you to watch how this happens. In order to do this proof, I'm going to draw a dotted line here. And what I'm going to do is I'm going to assume that this dotted line is parallel to the bottom of this triangle. And so when I do that, what I'm basically operating under is this assumption here. I'm going to label the three angles of this triangle. 1, 2, and 3. And I've also created two other angles, 4 and 5 here. Okay? So I know that this line, I'm going to call it L. So L is parallel to the base of the triangle. We'll label it A, B, C. Triangle ABC. Okay? Watch how this works. It's really actually pretty cool. So if then I go ahead and I take the next logical step, I'm going to say that angle 4 is congruent to angle 1. And the reason I can say this is because aren't they alternate interior angles? Because this is the transversal here of two parallel lines. So, and so by that same token, I can say that 5 is congruent to 3. For the same reason, alternate interior angles. Okay? Now, here's where the kicker comes in. I can say that the measure of angle 4 is equal to the measure of angle 1. And I can also say the measure of angle 5 is equal to the measure of angle 3. Both of these are because that's the definition of congruent. Now here's the real kicker. This line here, L, line L is made up of three angles. So what I can say is the measure of angle 4 plus the measure of angle 2 plus the measure of angle 5 is equal to 180, right? Because they're all in a line. This is a linear triplet, as it were. And the reason why I could say this is angle addition postulate. Now watch what I do. Because 4 and 5 can be substituted for 1 and 3, okay? If I take this, I can say, take out 4 and 5, and now I'm going to say the measure of angle 1 plus the measure of angle 2 plus the measure of angle 3 is equal to 180 because of substitution. So that gives me 1 plus 2 plus 3 is 180. It's a pretty slick little proof, okay? So that's what we're operating under. That's the proof that we're working with. We gave some reasons for the things that we said, okay? And so when we go to the next little part, we're skipping the surveys of France. We'll talk about that in class, okay? We've got a couple of corollaries. The acute angles of a right triangle are complementary. Think about this. If I've got my triangle here, and this is 90, and I know the total is 180. So if I take away 90, I would say that 90 is left for two angles. Okay, so that makes sense. The measure of each angle of an equiangular triangle is 60. So if I have triangle here, each angle is 60 because 180 divided into 3 pieces is equal to 60. Okay, so these things actually make a lot of sense. Okay, when we look at example 2 then, we're assuming that we're working with a right triangle, okay, and the measure of one of the acute angles is given. So we have basically 180 degrees to work with. We take away 90 because it's a right triangle, then we take away the one that we know, the 22.9. So when we end up doing this subtraction, it's going to be 90 minus 22.9 is going to leave us with a total of 67.1 degrees. Okay, that's the third angle. 63.7, same way, 180 minus our right angle minus our 63.7 is equal to our 26.3 left. It's pretty simple, guys. When we get down to this x thing, it's the same exact way. We've got 180 minus our right angle minus our x. Well, then we have 90 minus x left. That's it, guys. That's it. Because when we have x, it's some angle. It could be 5, it could be 10, it could be 26. We don't know what it is, but it's 90 minus x. Same way we did that before. Exact same way here. Once again, if you want to try these examples when I've got like 4 or 5 in a row, try them. Pause it and try them. I'm just going to keep rolling through though. 180 minus 90 minus 48 and 2/5. I'm a fractions kind of guy, but if you want, you can convert to decimals. Okay, and our answer is going to be 41 and 3/5 left over, or 41.6. Okay, guys, like I said, this stuff I'm going to give you 4 or 5 examples, but you can go ahead and you can try them on your own and pause whenever you would like. Okay, moving on to the next one. When we're describing angles in a triangle, we've got 2 different parts, and I'm going to go with a little bit of green on the inside here. This is called the interior, like the inside of a house. And we go out here, this is going to be the exterior. Everything out here is exterior. So the interior is going to be inside, and the exterior is going to be outside. Okay, so when I say interior angle, what is it that I'm talking about? Well, an interior angle is going to be formed by 2 sides of a triangle. Here's one, here's one, and there's one right there. Okay, so there's 3 of those. An exterior angle is going to be one that is formed by one side of the triangle and the extension of an adjacent side. And so it's formed by one side. So this is our exterior angle right here. And it's formed by one side of the triangle and the extension of the adjacent side. So when I'm talking about a remote interior angle, I'm talking about an angle that is, and the way we describe this is the one that is not adjacent to the exterior angle. And what this looks like is the remote interior angles, there's two of them, and they're going to be these right here. A lot of arrows going on here, guys. But the interior angles are all of them go inside. The exterior angle is on the outside. And the remote interior angles are the other two that are not next to it. Okay? So, how are we actually using this? The exterior angle theorem. The exterior angle theorem says the measure of an exterior angle of a triangle is equal to the sum of the measures of the remote interior angles. So let's say that this is 120. So that means that the measure of angle 1 plus the measure of angle 2 is equal to 120 as well. Okay, so these two together are going to be that. Okay? Application. I know a lot of this has been definition so far, but we're going application right now. We're going to apply this theorem in this way. When we apply the exterior angle theorem, we are going to say that 126 is equal to the two remote interior angles. So 6x minus 1 plus 5x plus 17. I'm going to simplify my terms. I've got 11x plus 16 is equal to 126. I'm going to subtract 16 from both sides. Okay, so 110 is equal to 11x divided by 11, and 10 is equal to x. Now, the measure of angle J is going to be 5 times 10 plus 17 is equal to 67 degrees. Okay? You see how that works. Here's one for you to do. Go ahead and try this one. Because if you try this one, you can get this one right. You come into class tomorrow, we got this one rolling for you. Alright? So try this one. I'm going to give you a hint. I'm going to start you off. This angle measure goes right here. It's going to look something like this. So I've got this exterior angle, and I'm going to set that equal to the two remote interior angles, which is going to be 90 plus 2z plus 1. And when I combine my like terms, I'm going to have 91 plus 2z, okay, is equal to 6z minus 9. I'm going to add 9 to both sides. So I'll have 6z is equal to 100 plus 2z. I'll subtract 2z from both sides. This goes away, so I have 4z equals 100. So z is going to be 25. And if I want to find the measure of angle ACD, ACD is going to be 6 times z minus 9. That's going to give me 6 times 25 minus 9 is equal to 141 degrees. Okay, so that's how this theorem works. When we talk about the exterior angles theorem, that's what we're talking about. Last one, third angles theorem. If two angles of one triangle are congruent to two angles of another, then the third pair of angles are congruent. So as you can see, we have two angles marked with one arc mark, two angles marked with two arc marks. So we can draw this conclusion that these two angles here must be congruent. That's our conclusion, okay? And so when we go down here, here's what we're saying. I have two triangles. Angle A is congruent to angle D. Angle B is congruent to angle E. So therefore, and this little symbol means therefore, angle C must be congruent to angle F. So what I'm going to do is I'm going to say y squared is equal to 3y squared minus 72. And I'm going to solve in this way. I'm going to make that positive, so I've got y squared plus 72 is equal to 3y squared. Subtract y squared from both sides. This goes away. I've got 72 equals 2y squared. Okay, I'll divide by 2 on both sides. 36 equals y squared. So what that means is if I want to find the measure of angle C and the measure of angle F, then C is y squared, so C must be equal to 36. which means that F must be 36 degrees as well. That's how the third angles theorem works, guys. You should start to see that we're just substituting, and all we're doing is working out these problems based on what the theorems say. All right? Thanks for watching.